So good morning, everyone. My name is Dave Turnbull. As Joe mentioned, I'm with Enerspec Energy Consulting. We are a Natural Resources Canada licensed service organization. Who's my other EA in here? There we are. Okay, so I just kind of want to give a quick brief, and if I'm being honest, it's because these guys are paying the freight. This is a paid political announcement from your government. Local energy efficiency partnerships. Oddly enough, something that we don't do a lot of in Alberta. I think you've had a few sessions down here. Where I'm from up in Edmonton, we actually haven't had a LEEP session since 2016. We're going to try to fix that. But local energy efficiency partnerships, to start off with, I have to show this disclaimer. I'm contractually obligated. I would call your attention to this line right here. The presentation and comments by the presenter, that's me, are distributed for informational purposes only and does not reflect the views of the Government of Canada, quelle surprise, nor constitute an endorsement of any commercial product or person. So when we're talking today about what's available out there, I am not allowed, we are, as energy advisors and service organizations, we are not allowed to recommend contractors and or products. We have to remain a neutral third party. All right, our agenda for today, and I'm just going to repeat what Joe did because that's what these guys tell me I have to do. We're going to do the introduction to LEEP. That's going to take a couple of minutes here. And we're going to, this whole session is about building to that fourth section, okay? I'm going to apologize in advance. You know, we called this air source heat pump training. We're probably not going to even mention air source heat pumps until about the middle of the first presentation. So I just beg your indulgence. We're going to set some context, some groundwork, and then we'll get into some of the air source heat pump stuff. The second session is going to be mastering controls for optimal heat pump performance. There are a number of different ways that we can control heat pumps, and what this section will do is this will give us some information on how to do it both economically and with an eye towards reducing greenhouse gas emissions. And they may not necessarily be the same thing. Heat pumps and panel requirements, so how heat pumps can affect your electrical permits. And the final one is we'll be going into the air source heat pump sizing and selection web application. So this is something new from NRCan. It used to be just a spreadsheet, an Excel spreadsheet. They've actually made some improvements to it. And now it's a web-based application that's available for anybody. There will also be a QR code that'll give you access to that as well. So what is LEEP? LEEP, again, local energy efficiency partnerships. They work with Canadian industry to make homes more resilient, energy efficient, and affordable in the face of climate change. You'll notice that actually energy efficiency takes second space to resilient, and that's intentional. They are very, very much into resilient, making homes resilient. We just spent a little bit of time in Jasper here last year helping them with the build back, and you know, we continue to be engaged in that sort of thing. They've been in operation for 15 years. They work in 10 provinces, 25 plus municipalities, 50 plus manufacturers, and they host 50 to 60 events per year. I think they would like to make that a little bit more. So if Calgary wants to throw some of these things, they're on board for it. So where is LEEP? They are right across the country. And what this slide shows is just with the same technology, what the different challenges are depending on the jurisdiction, okay? So in Alberta here, we have electrification and heat pump best practices in new housing. In Quebec, they're dealing with managing peak loads. That's their big challenge. So while we have the same technology, we're talking about the same kind of technology in these slide presentations, each one, the local part of LEEP, tries to make it pertinent to the area that we're doing the presentations in. So most of this will be pretty much pertinent to the province of Alberta. There's a whole bunch of different programs through LEEP. I look at this and my ADHD just goes all squirrely. It's like there's just squirrels everywhere on this. But these are all the different programs that these guys have presented. I think there's a few coming up again through ENBIX. You're doing basically envelopes. Are you doing windows too?
We're doing the window technology,
Yeah.
and we're doing a wall series coming up this
Yeah, so that'll be covered under envelopes. So there's a number of them available. So again, if anybody at Build Calgary wants to get in touch with LEEP and put on some of these things, they are more than willing. Call to action for industry, we need you. LEEP is very much industry driven. Industry has the opportunity to contribute. We have, and our company, we've been contributing to this for the past 7 years. The builder that I used to work for, we were contributing to LEEP for a number of years. There are other builders, HVAC contractors, insulation companies, engineers, building scientists. It's a whole team approach that comes into building one of these presentations. So what they've come to realize is that, you know, HVAC contractors and builders have influence. We want to be able to create trust with the clients, right? I've been in this business for 40 years, and the most contentious relationship I've ever seen in my life is that between a home builder and a homeowner. The home builder thinks the homeowner is being unreasonable, and the homeowner thinks that the builder's out to screw them. Neither one is true. We have to do a better job of setting those expectations for clients, and as an industry, we have to be able to meet the expectations of those that we set. Confidence, a homeowner's overall experience in installing a heat pump will inform their confidence in recommending a heat pump to someone else. If we put something in, and I'll stand on a soapbox later and talk about things like turnover and stuff, but the homeowner experience has an awful lot to do with whether they would recommend not only your company as a service or your company as a home builder, but whether they would actually want to use that technology. Learning objectives. In the first section, we're going to talk about sizing. This is absolutely riveting stuff. I have to tell you, we're going to talk about the heating loads of the house. We're going to talk about understanding the homeowner's needs. We're going to understand, in the second one, we're going to understand the implications of the controls approaches on energy, greenhouse gas, and operating costs. This is one of those adages where you can have 2 out of the 3. You can't have all 3. It's that old good, cheap, and fast equation. You can have 2, not 3. We'll understand the impacts of air source heat pumps and electrification on electric service panels, because there is a story there. I know in Edmonton, all developments are going to 200 amp. How are things in Calgary here? Are we still on a 110 service?
A lot of 200.
There's a lot of 200 going in? Yeah. Okay, is it a mandatory thing or is it kind of optional to the developer?
I believe NMAX mandates 200.
So NMAX is mandated 200 amp. Okay, so in this section, we'll give some strategies as to why maybe that's not necessarily required. And then we'll talk in the last section, this all builds up into that last section, is using NRCan's air source heat pump sizing tool for a data-driven approach to quoting on retrofits or quoting on new builds. It'll allow us to basically give homeowners or your builder an option or a few options. If we do it this way, this is the result. If we do it this way, this is the result. And it's a dynamite tool. It's pretty easy to use once we have the information from the other 3. All right, we've already discussed our roles in the housing industry, so I think we can kind of blast past this one. 81% of homes in Alberta are heated with gas furnaces. I think that stat might be a little bit low. Where I find we get into electrification and, God forbid, heating oil is in the northern part of our province. Actually, until we started the Greener Homes Grant, I had never seen a oil furnace in live person. So that was a bit of a shock, going up into the Peace Country and finding some oil-based product. But incentive programs and fuel costs have made a compelling business case for homeowners to switch to hybrid heat pump systems. In 2021, the federal government came out with the Greener Homes Grant, which offered $5,000 towards a heat pump. This turned out to be a really good opportunity for HVAC people to upsell from just an air conditioner to give the client not only an air conditioner, which generally heat pumps operate more efficiently than your standard air conditioner, but to offer a heat pump that will offer them some energy savings in the heating season. With a air conditioner, I think our typical cost on an air conditioner is somewhere around the $5,000 to $6,000 mark. Air source heat pump is usually in the $11,000 to $12,000 mark, so that $5,000 rebate pretty much covered the extra cost. And people, even in Alberta, took just almost rabid advantage of it. It was, we did this program, we did somewhere close to between 4,000 and 5,000 of these things. And I would say solar was number one in Alberta, windows were number two, but right behind windows was an air source heat pump. There was a lot of these things that went through, at least in our experience. With better performing air source heat pump systems, operation costs may be competitive with furnaces, and we'll talk about that in the next section. Increasing the consumer awareness of CO2 emissions from space heating. Like I say, the rebate programs absolutely drove this. And it was a good thing. Now that people have it out there, people are less afraid of these technologies. So it's actually a really good thing. You know, so if a builder, you know, if we're talking about doing a highly energy efficient home and we're adding an air source heat pump, the client is less likely to be scared about that kind of technology because chances are they know somebody who already has it. And there's a strong business case for heat pumps in more remote communities. Again, when I go up, when you're converting from oil to just about anything, it really makes sense. The air source heat pump really makes sense, especially when you're converting from oil or if you're already on an electrical-based fuel source. Heat pumps are one of the biggest investments. I have no idea where they got $3,000 from. My HVAC guys in here, I think I'm pretty safe in saying that we're talking around $12,000 for one?
No.
No?
No. Well, it depends, like electric versus gas hybrid, right?
Yeah.
Like
So
the gas hybrids as low as 8,500.
8,500?
Yeah.
So just to put in the exterior unit, a coil, and off we go? So you're about
85 to 95.
85 to 95? Okay. All right, so that's good. I still think it's nowhere close to 3,500. I have no idea where they got that number from. But cold climate air source heat pump, they're saying it starts around, in central system starts around 11 to 21. Somebody making money at 21. Don's thinking to himself, I'm in the wrong market. All right, so challenges that we face with HVAC systems in our projects. I would presuppose, given this is Alberta, that most of our projects are going gas furnace, that sort of thing, HRVs, that kind of standard. Is anybody doing any work currently with air source heat pumps? Yeah, okay. What's that? I think I'm doing work with air source heat pumps.
Last couple of years,
Yep.
I'm not a plumber anymore, but I was plumbing the last couple,
10
years. And the last couple of years, we put in a few heat pumps.
Yeah.
The vast majority was just furnaces.
Just furnaces.
Floor boilers.
Okay. And just out of curiosity, while I've got you in the spotlight, so what was your what was driving that customer experience? So why were customers looking at getting into that?
People were asking for it more when the grants and
Yeah. So yeah, so it was the grant that was driving that. Yeah. Which makes perfect sense. That's exactly what we found.
dropped off.
Some of the people they want all electric, like
Yeah. So
request.
yeah, so some people are requesting just to get rid of gas altogether.
They don't, yeah, we've done several where people take the gas out of their house.
Yeah. And there is an economic case for that because in Alberta here we spend about between $600 and $700 depending on the jurisdiction per year on standby charges for our natural gas. When I looked at my natural gas when we were preparing for this, my largest expense was not the consuming of the material itself, it was all the standby charges. So when we dropped that extra $700 helps offset the extra cost of the electricity.
What I've seen is all the people that do all electric, they also do solar and they also do windows.
Okay.
It's in
Yeah.
and like we had one guy, like R40 walls, like, they go nuts. They wanna keep their efficiencies up.
We don't use the word nuts anymore. It's mentally hilarious. It's,
Depends if you're assembling something or not. Where's your mind?
yeah.
Mechanical mind.
Yeah, yeah. No, and we're actually going to talk a little bit about that, I believe, in the third one where we talk about the electrical loads and how we can augment these things, and also in the fourth one where we kind of bring this all together. I should point out that air source heat pumps are, they're a part of the landscape of going towards a low carbon emissions, but they're not the only thing, and we'll delve into that a little bit better as we go along. I'd like to introduce you all to our case study home today. This is a single family home. We did Edmonton because that's what I have lots and lots and lots of. This is a home in the west end of Edmonton, pretty typical, front attached garage, narrow, because lots aren't getting any bigger. But 3 bedrooms, 2024, built with a centrally ducted gas furnace. There's no AC in this thing yet. And we're just presuming that the homeowners are going to be concerned about long-term utility costs. So today's goal as we go through this presentation is to identify a cost-effective solution. They put heat pump in there, but you know what? We're going to throw everything on the table as we go. We're going to identify a cost-effective solution that can best meet the needs of this home and the family using the data captured on this house. Now, the one thing that I will say about this house is this has had a full EnerGuide on it. Okay? So this has had a blower door test. We know what the air changes are. This has actually been rated properly, which actually aids in running through this exercise. Okay, so the key takeaways off of this one: in many cases, operating costs of gas furnaces may be competitive. So we're actually gonna experiment with that a little bit more. Installing an air source heat pump is different than furnaces, so we have to pay some close attention to sizing and a number of control strategies. This is not as simple as just taking a furnace out and putting an air source heat pump in. There's a certain amount of education that has to go with the homeowner. Otherwise, you're going to wind up with an awful lot of callbacks for things like, "Oh, my furnace isn't running," when it is. And when I say furnace, that is the generic term that everybody uses. They don't call up and say, "My air handler isn't working." They don't call up and say, "My air source heat pump isn't working." They call up and say, "My furnace isn't working." It's kind of like Kleenex of the HVAC industry, if I'm being honest. NRCan has some tools and resources to support industry with heat pumps. So again, in addition to the tool, there's a bunch of guides that we also have access to, and we'll talk about those in the 4th section. So there's that one done. Leap over and done with, so apologize while I switch over to something different. Welcome to the 1st section. This is making the case for a CSA F280-12 heat loss calculations. First question I have is, anybody doing this as a matter of course in their builds today? I take it that's a no. Okay. I'm not surprised. This has been in the building code for quite some time, probably since 2016, 2016 here, 2010 nationally. But the CSA F280, it's a heat loss calculation, and it's actually, as we start to build more and more efficient homes, it becomes more and more important that we do this. So what is an F280 calculation? Why should we care? We'll explore what happens when a rule of thumb is used versus an actual F280 calculation, and we'll explore that with the case study home. We'll talk about sizing considerations, considering the temperature dependence of performance, because of course different heat pumps have different what we call heat pump curves, so they work with different efficiencies at different temperatures outside, and some will go down. The cold climate air source heat pumps will go down into the -20s, -30s for some of them, and if you're looking at a regular air source heat pump, you're probably looking at it, you might be cutting that thing off just above 0. We'll talk about how we would do an F280 calculation, and again, we will repeat ourselves. We're going to tell you what we're going to tell you. We will tell you what we are going to tell you, and then we will tell you what we already told you. That's basically how this is all going to go, okay? What we've heard from builders. Common issues with HVAC design. Experience overheating on shoulder seasons in some rooms. Rooms over garage, second floor rooms. Throughout this presentation, I throw my home under the bus a lot. My home was built in the mid-2000s. I live in a very energy efficient home. And at that time, there were certain types of thinking that were going along with the energy efficiency that are not in the current line of thinking because we know better now. And we'll talk about those as we go along. Placement of an outdoor unit. I don't know about the city of Calgary, but I know in the city of Edmonton, if somebody complains about your outdoor unit, they will walk out there with a dB meter, stand 2 meters away, and if you are over 50 decibels, they will force you to move it. Is that the same here?
In Edmonton?
Yep.
The city of Calgary is, we went through that several times and they've never issued any issues even with that.
Yeah, it actually started in the infill is where it started. It was the infill market that created this issue, and it just, as many builders here will understand, many issues that happen in the infill spill over into the greenfield.
We had a
So
customer that insisted his house was being cold from the heat pump and made a big stink about it. So that
interesting.
we got the city involved and they talked to him and said there's nothing to see. I guess 45 dBs blowing cold air out to the outdoor, and it faced their house, and he believed that it was making his house cold.
Interesting. So the outdoor unit, while it was operating, this person had the idea that it was going to cool down his home because of the, make his house colder. And this is the neighbor.
The neighbor.
Wow. That's grasping at straws, that is.
It was one of those things that, but
Yeah.
but
Yeah.
the city inspector guy said they've never issued like citations.
Yeah.
Even
In-
noisy
Yeah.
ACs out there.
Yeah. In Edmonton, they will ask you to move it. We haven't had any problems with it because generally AC units and air source heat pumps do operate below that threshold.
Yeah,
But people get a little crazed. Yeah, we can't.
now there you go using those words.
No, I said crazed. I didn't say crazy. They're crazed.
I use the words.
You use those words. Okay, you're allowed to. I'm not. Okay, so placement of the outdoor unit is a challenge. Space for ductwork is becoming more of a challenge in homes. We have open concept homes, not a lot of walls. Everybody competes for real estate. Plumbers, HVAC guys, electricians, they get whatever's left over, which is okay. They've just got skinny little wires. They don't need that much room. Keeping costs low to remain competitive. I don't know of any customer who wants to pay 1 cent more for something than they have to. Can we agree on that? So frequent callbacks. One of the things that I have in my practice an awful lot is I get calls out for rooms that are cold. And while there's a number of reasons for it, it's not usually what the homeowner thinks it is. Oh, I'm missing insulation or something. It's almost never that. And it usually has to do with either a sizing or a distribution issue. So we can leverage the NRCan air source heat pump sizing and selection app to resolve key issues on performance. Mechanical systems don't sell homes, but their outcomes can. I think we can all agree on this. Nobody bought a home because of the furnace that's in it. Everybody assumes that there's a furnace in a home and that it works properly. And what happens when it doesn't? They scream from the highest heights. So while sizing things properly and doing our jobs correctly may not necessarily enhance our reputation as companies, it absolutely has a bearing on how we retain our reputation as companies. Okay, and everybody has different triggers. This is the one that I see the most of. Is achieving comfort. Dealing with the city of Edmonton right now. Yesterday I was a little late meeting Joe downstairs at the hotel because I was doing an F280 for a home that the customer's upset because when it's minus 40 outside, he can't keep it at 28 degrees. I'm not certain why there's that disappointment. But again, their perception becomes our reality, right? So what happens when a heat pump isn't sized properly? And actually this, we talk about the heat pump, but I mean, we can call this pretty much insert any type of mechanical into that. When you're undersized, you have a risk of not meeting heating and cooling loads, the greater reliance on your backup or your supplementary heating system, risk of higher utility costs, depending on the supplementary heat system you're using, greater greenhouse gas emissions, and risk of poorer occupant comfort. And of course, that's the one that's going to cause us all the grief, right? Oversizing a heat pump, we have higher capital costs to start off with, right? We're paying more for the materials. Risk of poor performance because we're short cycling, right? It's the same thing we have with a furnace. What I give as an example is the company I used to work for. When I got into my position, the very first thing my boss had me do was go and have a chat with our mechanical contractor, because we had a model of a home. This is in 2005. It was called the Catalina. It was around 1,800 square feet and featured a 95% efficiency furnace, 2-stage variable speed motor, 100,000 BTUs. Had a small bomb going off in the basement every single time. And the argument that I had from the mechanical contractor was, I don't want to be called out in the middle of winter between Christmas and New Year's when it's minus 40 outside and they don't have enough heat. There was absolutely no danger of that happening. All they had to do was turn the furnace on and a small bomb would go off in the basement and they would have heat. What did happen was the homeowners that bought these had terrible occupancy comfort issues in the bonus room, because at 100,000 BTU we had one thermostat on the main floor. It was actually very much like my house, and I will throw my house under the bus with this as well. The thermostat was near a back hallway that already had a vent right beside it, so that thermostat was getting satisfied very quickly. Right? So the furthest away, not getting anything, what was there was satisfying the T-stat so quick that the rest of the house stayed cold. So we have the reduced equipment lifespan because of the short cycling. It's just like a vehicle. Vehicles like to be run long. Start and stop traffic is the hardest thing on any vehicle. They'll tell you that. It's also the hardest thing on all your mechanical equipment. Risk of noisy ductwork and high static pressures if we're oversizing equipment for what we have for delivery systems, that becomes an issue. That draws a higher current on the electrical panel, and we'll see how that goes in section 3 of our discussion today. And again, risk of poorer occupant comfort, more in terms of dehumidification. All right, if we've sized this thing too large, we have too much air going across the A coil, and it's not getting a chance to dehumidify when we're in the cooling season. And that gives us a nice, cool, and clammy occupant. So what is F280? It's a calculation method for calculating both heat loss and heat gain, okay? And it allows us to select the appropriate output capacity of both space heating and cooling appliances. Furthermore, there's a couple of different ways we can do this. We can do a whole home, or we can do a room-by-room calculation. So it can actually assist us in creating a mechanical design if we want to go that far. Key points for builders. Carrying out the F280 heat loss analysis will right-size your heating and cooling systems, will improve comfort, and optimize your cost. All right. I have to say that in the last 20 years, I think mechanical contractors have gotten a lot better at sizing things. I don't know if we're completely there yet. I still see when we go into some of our builders' homes for energy evaluations, I'm still seeing some sizes that I'm not too crazy on. I think they could have gone down a size for sure. Considering upgrade options, it'll give you some options as far as, what can we use to meet these heat loads? Does it have to be a furnace? Would somebody like to do something else? Completing standardized and comprehensive performance details when submitting your plans for analysis. The softwares that we talk about will all spit out a standardized form that all authorities having jurisdiction will accept. This is something that NRCan has worked on for the past couple of years. Did not exist, I would say, even a year ago. Reviewing heat loss and gain results helps ensure the results are right and lets you see where you may want to focus. When you're looking at a particular home and you're seeing that you all of a sudden have an abnormally large cooling load because you have 30% fenestration in the home all facing west, we may want to revise our design on something like that. Let's look at some solar shading. Let's look at not having 30% fenestration, shall we? And making sure your heat loss gain professional is accredited, experienced, and using the software that is certified. That's very important. The design condition context and the factors that tend to make most affect equipment sizing. So when we're talking about design heat loss, which is what most of us are concerned about in Alberta, this is how your heat loss is generally made up in a standard home. Okay, 40% is from walls, 22% from glazing, except if we have 30% fenestration. Your floors, ceilings, and air infiltration. I think that number might be a little bit high these days. I'm pretty sure, especially in Alberta, we're building homes a little bit tighter than that. But that is what makes up your design heat loss. Your design heat gain is somewhat different. This big orange thing is your glazing, okay? And this is where I throw my own home under the bus. Back in the early 2000s, when we were talking about energy efficiency, we thought that what we wanted to do is we wanted to get all that sweet, sweet passive solar heat gain that we could get, because it was free. It was free energy. That's what they taught us. They taught us it's free energy. So my house, we back south. My south exposure is virtually all windows with high gain coatings on them. In about 2 weeks, I will have cooling loads in my house. It is so uncomfortable. The good news is we can actually open up a window this time of year and relieve that, but it does really affect the comfort of the home. Also, there is absolutely no way in hell that my home could be built once we start getting into the tiered codes, because the tiered codes have a maximum cooling requirement. Okay, so as we move forward, we will probably see this come down quite a bit as we get into more of the sunstop glazings, the soft coat glazings, and things like that into your windows. But this is what goes into the design. This is what the design considers when creating the numbers and its outputs. So design loads, generally rules of thumb, will oversize every single time. Okay, using the CSA F280, we wound up with, in this particular house, we wind up with 38,000. A rule of thumb, before I started working with these guys, it was a 60 that was going into every single one of these homes. So just slightly oversized one size.
So that's a 5-ton 60, right?
Yeah.
5,000 BTU.
Yeah, 60,000 BTU, so 5 ton. 5 ton. 12,000 BTUs to a ton,
Yeah.
times 5 is 60,000 BTUs. So that's,
Sorry,
Yeah.
He said 60, this number would be more.
yeah. So this one here is, this is about a 3.5 ton, right? Bonus question for the class. When we talk about cooling in terms of ton, because actually heating's not done in tons, but when we're talking about cooling in terms of tons, any idea how we got to that term, ton of cooling?
It's a match, 12,000 matches per heat 1 ton of ice per hour.
You're close. It is the amount of energy required to take ice at 0 degrees Celsius.
Sorry, I should clarify. A match is 1 BTU.
Yeah.
My bad.
Yeah, so it's the amount of BTUs required to take ice at 0 degrees Celsius and turn it into water at 0 degrees Celsius.
For 1 hour.
Yeah. So 12,000 BTUs is what that's how we wound up with a ton.
The old days.
It's the old days. Yes, exactly. So when we apply a rule of thumb, like I say, this home used to have, they used to put in 60s very regularly. The cooling design, if I'm being honest, the cooling design used to come a lot closer to this. It actually, if anything, used to undersize it a little bit. So let's have,
It's a 2-to-1, it seems.
yeah. So let's have a look. So we allow for smaller equipment. So we talked about that earlier. That usually saves you a little bit of money on the build itself. It also allows you to have smaller ductwork. It'll allow you to have fewer and smaller bulkheads and smaller AC equipment. So there's a lot of benefits to properly sizing the mechanical equipment, not just for air source heat pumps, but for your own furnaces, et cetera.
That's the challenge. You're almost a 2-to-1 ratio, almost. Heat
Yeah.
pump to AC. So you
Yeah.
really can't go 1-to-1. It's got to be a modulating unit.
Yeah, and so what we have is we still in a predominantly heating climate. So sizing the unit just to the cooling does have its detriments, and actually this is what we're talking about as we go along here. So properly sized equipment for cooling and dehumidification, how do we get there? One of the things that NRCan has found that typically one of the rules of thumb is 400 CFM per ton of cooling. Is that kind of the number that we use? And so what they did is they did a little thought experiment for this, and they said, listen, if we have no dehumidification, and what happens if we're running 400 CFM per ton, and what happens if we're running 350? By actually decreasing the airflow a little bit, we actually increase the dehumidification, which improves the comfort. And what we're doing is we're slowing that air down across the coil, so it gives it a chance to condense on the coil and be removed from the air. Very counterintuitive. You would think, oh, I want to get as much air past it as I possibly can, just so that I can get more air past it and take out more water. It's actually, if we slow it down, it works better. So go back to our case study home. Just remind everybody, 1,900 square feet, built last year. Having done the F280 analysis, now what we can do with it, we have the temperature heat loss. We will create a load line. We will overlay the heat pump capacity curve. And this will vary from brand to brand. The web application has many of these already in it, and we'll talk a little bit about that at the end. But you want a system that meets most of the heat loss, heat gain, and provides good energy performance. So from the F280, the design heat loss at minus 30 Celsius comes in, like I said, a little bit over 35, about 38,000 BTUs. And this plots our load line. So what we know is as it gets warmer outside, we have less and less heating requirements, okay? And this is just for this house. There are homes, as we start getting more and more into the energy efficient homes, this comes all the way down. We've had examples of homes in the last couple of days that people have brought to our attention that, you know, their heat load is down around here on a fairly big home. It's what we call a passive house. It is an extremely well insulated, tight building enveloped home. So onto that, we will throw the heat pump curve. So this is the performance curve of the heat pump. So as the temperature goes up, the ability for this thing to generate heat obviously goes up, but you know, once we're into the lower temperatures, we don't have an awful lot to offer, okay? And this is kind of a standard thing for most heat pumps. There's not as much energy in the air for them to absorb, okay, with the current refrigerants that we're using. Now, as refrigerant technology improves, this will improve as well. We made a real big jump about 10 years ago into the cold climate air source heat pump. That was not so much a refrigerant technology, that was actually the compressor technology that assisted with that and how the valves worked, the expansion and expansion valves. So below this, supplemental heating is required. Anything below this point here. So it's where these two intersect. This is what's called the thermal balance point temperature, or TBPT. I'm going to call it the thermal balance point temperature because if I try to say that too many times, my tongue is just going to fall out of my head. So we've identified that. So that is also going to inform some of our control strategies in the next section. Okay, so just kind of keep that little graph in mind. Okay, if we know the load, software can calculate other useful metrics like operating costs, greenhouse gas emissions, the fraction of annual heating needs that are above the thermal balance temperature. So in this particular home, what they found is with a temperature balance point of minus 12.8. So in some of these slides, it says 12. In some of these slides, it says 13. We're actually still talking about the same point, okay? That we found that 70% of the load is above the thermal balance temperature, okay? So that means that it actually works out to less than 2% of the heating season load is below or actually requires the supplementary heating system. So
Which is very little.
it's very little, but it's still there. Let me tell you, if it's minus 40 outside and you don't have heat, even though it's only like 2% of the year, somebody gonna complain. All right, so using the sizing tool with the information above, you can use the NRCan sizing tool to easily determine your costs, energy savings, and greenhouse gas savings. So like I say, the F280 is the baseline for all of this. Allows the homeowner and or the contractor to explore different options, including products, sizes, and control strategies. The new sizing tool was developed to fit this, and we'll take a deep dive later today. This summary kind of comes up in every single one, so this is the one and only time I'm going to mention it. It becomes very, very redundant after the third or fourth one that I do. Okay, opportunity is in knowing the load. If we know what the load is, we can deal with it. It's just like anything else. So if we know what the load is, we can install a right size system that meets the homeowner's needs, makes them happy, gives them good occupant comfort, which is really what we're looking for. Meets affordability and or greenhouse gas emissions goals, lower upfront costs. We're right sizing the equipment. We're not charging them anything more than they absolutely have to pay, which is kind of in line with what the consumer wants. And we will reduce the callbacks and lower your warranty calls. Nobody likes to go out a second time to have a look at something, especially if it's a perceived issue, right? I'm not comfortable. Well, comfort is so subjective. Like I said, I was dealing with a guy who wasn't comfortable because his home wasn't 28 degrees Celsius all the time. I have no words for that. I have no words. So how do we do an F280 calculation? First off, like I mentioned, this should be done by somebody who is accredited and qualified. There's two options, and this is again where I may not necessarily agree with the point of view of the Government of Canada, where they've given a thumbs up and a thumbs down to these two options. I give a thumbs up to both of these, personally. The first option is probably 2 thumbs up. Okay, so that's 2 big thumbs up, where we do a room by room analysis. It is required for new construction. It is in the building code. The code officials generally don't call for it unless there's a problem. All right. And the reason for that is, honestly, I don't think there's enough mechanical designers in the country to do that work. We do a little bit of it. I just kind of do it as a hobby. It's not something I wanted to commit to because it is quite time consuming. To do a proper F280 calculation, if you have good software, is probably anywhere between half and 2/3 of a day, depending on the size of the home. Maybe a full day if it's a big one. Okay, so there are some you know, you look at that and you say, okay, in Alberta, how many homes did we build last year? 30,000. So we got 30,000 days worth of doing this, and I think in the province of mechanical designers that are registered, I think we only have like not even a dozen. So we clearly do not have the capacity to do this, okay? But it is something that will be coming, and as authorities having jurisdiction receive more and more complaints on energy efficient homes that haven't done this, we will see a call for this a lot more often, okay? So I propose option A, 2 thumbs way up. It's a room by room calculation, requires a full takeoff and data entry. It is 100% accurate. We know exactly what room requires what kind of heating. Option B, though, is a really good start. So for my home builder peeps in the room, I would, if you're running down the performance path of the building code, talk to your energy advisor. There's some software that will sit on top of the software that we use, which is HOT 2000, and it will do a whole home analysis so that we can at least get the mechanicals sized properly. This will save a lot of grief, okay? It's useful for retrofits. It's allowed for retrofits because with retrofits, we don't actually have to demonstrate an F280. The takeoffs are already done, okay? The energy advisor has to put all these calculations into their software anyway, so it's all already done for you. Minimizes the additional work. So with this second system, speaking with a fellow yesterday, it actually takes them longer to fill out the paperwork than to actually do the calculations with the software, all right? So much, like on an order of magnitude, much easier to get done. Takes less time, but not as accurate. And the only reason it's not as accurate, you will get the right sizing of the equipment. You just will not get the right sizing for, what do I need going into a bonus room? What do I need going into a half bath? What do I need going into the master? Okay, so it won't give you that, but it's a great start. Let's just start by getting the mechanicals straight. These are the different technologies that are available, the different softwares. The one that I'm most familiar with is the RightSoft, only because they came out first. They are no better, no worse than any of these guys. The fellow that I talked to yesterday, he uses Heat and Loop CAD. He loves it. He says it's great software. So there's another endorsement. But the software that your energy advisor has access to is this Volta Research, Volta Snap. Okay. This can allow your energy advisor to give you an F280 to size your mechanicals properly, and it will stand up, because at the end of it, you get one of these. This is the standard CSA F280-12 form. So all of those softwares that we talked about here will spit this out, and it is accepted. It's actually gone through a whole bunch of iterations through NRCan in conjunction with the codes officials within Canada. So everybody will accept this. All right. So it's an easy thing to do. Do you have the Volta?
I have used it a bit, yeah.
Yeah. Yeah. Okay. Yeah. The hardest thing about the Volta is the Snap is actually getting the software. They don't make it easy. But once you've got that, an energy advisor can very easily run that calculation. Yeah, the fellow I talked to yesterday, he says it takes him probably 20 minutes to half an hour to fill out the paperwork, 10 minutes to run the calculation. So it's actually a fairly efficient process, shall we say.
Do you
Okay.
know why that is? Like why they're so stringent on access to their software?
No, I have no idea why it's not that they're stringent. I think that the software has been under development for quite a while. They did a presentation here last year to the Canadian Association of Consulting Energy Advisors. And at that time, they were still tweaking a few things. But I think, you still can get it. It just takes some determination to find it. Yeah, it is available. It's probably easier for a service organization to get a hold of it than it is for just an energy advisor. Yeah, it's definitely, it's out there anyway. Okay.
The energy advisors like the NRCan, like this Ener guy, what software is it, 280 or was it the HOT?
The HOT 2000 does not do, the HOT 2000 will calculate loads. It uses a different model than an F280, so consequently it's not applicable to building code. Many building code officials will accept it because it uses what's called an AIM2 method, which oddly enough was developed by the University of Alberta in the late 90s. So it has a very Alberta-centric bend to it.
Usually Homer? You you know that one, Homer?
No.
Hot 2000 looks like the old Homer.
Oh, well, Hot 2000 is a software, is actually an amalgamation of a whole bunch of different softwares. And the Hot 2000 is actually the software that kind of puts everything together.
Is that what they use for like these Energuide?
That's what the Hot 2000 is what we use for the Energuide. Yep. So if you want to go in depth for the F280, HRAI is the outfit that offers the training. Okay. It's a 4-day course, runs around $700. It's online now. Back in the day, we used to have to go to Saskatoon in the middle of winter to take the course. So online has made this so much more better by far. So it's a 4-day course. The great thing about it for small companies, I would hope that sometime in April, at least according to the website, the federal government should be releasing more funds for the Alberta Jobs Grant. And the Alberta Jobs Grant for small companies will pay for 2/3 of that for an employee. If you're an owner-operator, unfortunately, you probably got to pay the whole bit of the freight. But if you have employees and you want to send them, they will cover 2/3 of that for you. Okay?
That's a good idea.
Okay. The course is phenomenal. I've had a few guys go through it. It basically does a walkthrough of the step-by-step process. Now, before the software, there was an Excel spreadsheet that you could fill out. And before that, though, was a handwritten sheet. And that's kind of been the evolution of this product. So what the course does is it takes you, walks you through the written sheet. So you've got a very painfully detailed version of how to get through this. So when they come out, people can actually do this for real. So the target audience is HVAC technicians and designers. I would also submit that energy advisors also benefit from this. Energy advisors and mechanical designers have a lot of similar skill sets, so it's a good crossover. Other considerations, and we're going to talk about those as we move along. Panel limitations. We may not have enough room in the panel. Ductwork capacity, especially if we're dealing with older ductwork. Anything newer, for the most part, looking for the HVAC guys in the room. We've been sizing our ducting for mostly AC for quite a while now, yes? Yeah, I think where we might run into some difficulties is maybe on some really old stuff where it's not set up to handle the CFM, but for the most part, I think anything within the last number of years is probably okay. Ceiling heights in basements. Older homes have lower ceiling heights, which can limit the size and or model of heat pump selected. You may not have room to put an A-coil into one of these things, so you may have to consider some kind of other air handling device. Location of the outdoor unit, we talked about that a little bit earlier. That can be a bit of a problem, particularly, again, if you have a zero lot line product and the home's only 18 feet wide and you've already got a 12-foot deck and you got a window in the basement. It's like, I guess we're putting the heat pump on the deck. So,
Under the deck. If it's a side discharge.
yeah, you got to be careful. Yeah, with the discharge on it, right? A lot of these things. One of the big things that I see from an installation standpoint is not having the clearance between the house and the unit. We see an awful lot of that, and the units failing. Okay, so let's compare outcomes. This is kind of where rubber hits the road. So what we did is we looked at 3 examples here using 2 rules of thumb. 1 rule of thumb size to the AC on this house. So the rule of thumb on this, we're going to size it to the AC. We're putting a 2-ton, and that's what we were talking about over here. We put a 2-ton in there, and we are horribly undersized for heating. Now we're definitely looking into a large backup. If we use the rule of thumb and where we're heating it, now we've used this rule of thumb. We're putting in a 4-ton unit, and we're almost double what we need for cooling. So going to your 2-to-1 ratio, right? So the Goldilocks version is we can actually use the proper numbers to size for both, and we wind up with a 3-ton variable capacity.
That's basically what we end up with usually.
Yeah.
And the 3-ton at minus 15 is 42,000 BTU.
Yep.
So everybody's happy.
Yep. Yeah, absolutely. And that's on a cold climate air source heat pump, right? So you're getting 15,000 BTUs out of a cold climate at that. Yep. All right. Key takeaways. Right sizing leads to better results. I cannot stress that enough. It's not hard to do. You know, talk to your energy advisor. They can talk to their people and get the software if they don't have it. And it's an add-on service that they can provide for you. Happier homeowners equal fewer warranty calls. I think we can all agree on that. Comfy and satisfied occupants. I don't say it gives you a better reputation. I think it maintains your reputation. Okay. I think we have a lot to lose. I think we all start off at a certain level, and we just don't want to fall from that if we can help it.
If I could just comment about that, we have this, sometimes a customer wants to save money, and I call it a save money option.
Mm-hmm.
And that's more of the, if you're looking back on the other slide, there's the cheaper version, one is either undersized
Mm-hmm.
or doing it right. And
Yep.
we have that problem with the customers. They always go by save money,
Yep.
and then there's do it right. They're not even close to each other. when
Yes.
it costs
Yeah. It
22 times.
yeah. It actually comes into that old equation of good, cheap, and fast. You can have two.
Well, they call it good, better,
You-
best, sales
yeah.
guys, and
Yeah.
save money. So,
Yeah. I don't go for good, better, best because usually the good and better options really aren't that good or better,
well, I call it the save money option,
right?
not really.
The one thing I've learned as a tradesperson is when I got into the trades, my first day on a site, I trained as a carpenter, and I showed up, had my tool belt, gonna frame a house with a 16-ounce hammer. This is long before we had air tools.
One size fits all.
Well, it was a 16-ounce hammer. My dad said, "Oh, that'll frame a house." And the guy picked it up, looked at it, and then threw it away and handed me this 22-ounce thing. Okay? What I learned that day is it never pays to cheap out on your tools. Okay? From a homeowner standpoint, it never, ever, ever pays to go the cheapest route. I'm a musician. You know, there's, in my business, you know, we go out, we play in front of people. I cannot have gear that breaks down in the middle of a gig. Just cannot happen because I don't have a backup. I'm out in the middle of Swinehoo's Git, Alberta. And, you know, there's no guitar stores or anything like that around, right? So we need stuff that performs. And I'm sure all the tradespeople in this room know exactly what I'm talking about. And it should be the same when we're talking to clients. It's like, yeah, you can buy this, but I would much rather you didn't, you know. And we kind of owe that to people. The thing I love about this country, and you know, we're going to be talking about this as we go forward when we talk into the economics of this. I have zero problems in recommending products that people have all the information about. So in your particular case, yes, here is your basic option, the low-cost option. These are the things that are going to happen.
Don't ask for performance or.
Don't ask for energy efficiency because it's not. Don't ask for performance on a really, if we're talking AC units, don't ask for performance on the hottest of days because it just can't get there from here. Okay? And you know, some people will accept that, some people won't. What I've kind of come to in my practice is that, yeah, you know what, not everybody that calls on the phone is my customer. And I've come to understand that. In my business, there's always going to be somebody that's willing to cut a quarter more than I am, right? And I have to be able to let them. And people, once they, you know, we explain the difference, and once they know the difference, they're free to make that choice for good or ill and live with the consequences. That is the beauty of this country, and I love it. Okay? So going back to this, the F280 is the best practice for sizing. There are other methods, like I say, the HOT 2000 has an AIM2 method that gets you close, but it's not accepted by the code officials. So if you're just relying on that information and you get into trouble, you're going back to do an F280 anyway. Hence my discussion from earlier.
Can I just ask about the F280? If you use that F280, we're not using it, by the way. But, we've got training on it. We just let's just say it's just too much work for our bother, to make a long story short.
Okay,
But if we started implementing it in our discussion with customers.
Yeah.
Versus the Hot 2000, which is the Enter guide.
Yeah.
I think part of it, we were using the Enter guide's numbers, which was that Hot 2000.
yeah,
Typically,
yeah,
they say they're that, well, we'll exceed that a little bit.
yeah,
And they save us a bit
yeah,
of
the
conflict, if you want.
yeah, the thing, there's two issues with that. So if you're trying to use the Hot 2000 as your sizing tool,
Well, we use the
yeah.
Enter guide's numbers.
yeah, the inner guide numbers, which comes out of Hot 2000.
Correct.
So when a homeowner gets an inner guide report, they get what's called a homeowner information sheet, and on page 2 of that homeowner information sheet is what can be recommended as to the size. That depends on what the energy advisor inputs into the software. So we do have to watch that. If you're working with an energy advisor, please ensure that when they're putting that in, they're using what's called a calculated method as opposed to user-defined. Because if they show up to a home that's got an EnerGuide, that's being done by an EnerGuide, and it's got a 40,000 BTU furnace in there, our obligation is to say this thing has a 40,000 BTU furnace. If it's a 60, we have to say 60. So when you get that, it may not necessarily be what's correct. What it might be is what's already there. Okay?
That is, of course, like the city of Calgary and the government, they use that Enter guide as their understanding. So
Yeah.
they see them as the
Yeah,
experts. So we have to-
it comes from an incomplete understanding of what's there. Okay? Yeah. When we're doing proposed modeling and stuff like that, like when we're doing just 936, we are allowed to put in calculated, and we are allowed to put in factors and things like that, which again, the F280 doesn't really have. It puts in its own. We actually input those manually, so we can manually oversize equipment within the AIM2 that the F280 doesn't allow us to do. Okay? So typically speaking, if I'm looking at an AIM2 method, when I'm doing calculations, preliminaries, and I've done all the heat loss stuff, and the guys kind of want to know what size, I will run that. I will run a calculation because, again, our design temperature is here it's minus 30, in Edmonton it's minus 31. I think we can all agree there are days in the year where we go below minus 31, right? So I do pad that by a little bit just to cover that off. And then what the software goes and does is they use that pad and then they add a little bit of their own. So we're twice as safe. And oddly enough, even when I do that and we're twice as safe, I usually wind up with smaller equipment than what the guy was going to put in the first time. Okay? But again, if it ever comes down to a dispute, you are somebody going back and doing an F280. Now, in the city of Calgary, I can't speak for because I haven't built here before. Who pulls the permit for the HVAC? Does the builder pull it or does the HVAC?
HVAC company.
So, yeah. So, but for new construction, it's for new construction,
We're on the permit?
you're on the permit.
Yeah.
Yeah, yeah. So whoever's on the permit for that has to provide the F280.
Usually it's the builder, right?
Yeah, yeah,
But we do retrofit, so it's us.
yeah. So retrofits, again, if you've got that and they've got that all done, have them talk to the company that did the initial energy analysis, and just have them use the VoltaSnap and get you something that'll stand up.
So there's a couple of conflicts, one being that Enter guide, the 2000 here in Calgary.
Mm-hmm.
And then the City of Calgary program is called the SEEP.
Yep.
Clean. That program requires 50% of your heat load. So if you're an 80,000 BTU furnace, you need a 40,000 heat pump, for an example.
I see.
And if it's kind of a numbers jive thing.
Okay.
If we take the 280, the 280 comes up with another number, and to the ears of the world, City of Calgary and the Hot 2000, they don't listen to that.
Okay.
So that was, so for us, we just said, okay, we use it as a guide. and we try to make something, hence shoot for comfort.
Yeah. So that kind of runs into some of, yeah. So,
Unfortunately.
yeah, so that kind of comes into this discussion.
So
And it also becomes part of the discussion around the controls and how we operate the controls.
Is a reference still good to have in-house, regardless of what other people do?
It's always good to have more information than less,
Absolutely.
you know. But again, you have to be aware of the context that information was created in. So if that's a house that's an existing home, chances are, if they're following what EnerGuide requires, and there was a 100,000 BTU furnace in there, that homeowner information sheet is going to say that there's 100,000 BTU furnace in there. So you actually have to contact the energy advisor, have them go back into the software, change that from a user specified to a calculated, and then it can calculate. And what they can then spit out for you is what's called a full house report, which the authority having jurisdiction will accept a lot better than an EnerGuide report.
You know, we've had to go back and forth through it.
Yeah.
So
Yeah.
that we can get the customer something that's gonna work.
The simplest solution, just go straight to the F280. Do not pass go. Do not collect $200 and save yourself all that kind of grief. Because the nice thing about that is it's absolute, right?
This
You're
would
you're
be,
completely in line.
When it comes right down to it, there's a conflict of it not working, we're basing it off the F280, which is standard.
Yeah, that's the
higher standard.
yeah.
That's right.
Yeah, that's the standard that the building code requires. So if you want to make sure for your own company's sake that you're always on side, this is where you want to go.
Yeah, we-
It is. It's absolutely time. But if we're doing for retrofits, if we're just doing the whole home F280,
Good way to
there's a quick and easy method for you to do that, and it's not expensive, and it will save you the grief. And then you don't have to worry about what I just talked about. Is the guy putting the furnace that was there in the report, or is he actually calculating it? You don't have to worry because it's already calculated. Okay?